All right, greetings, ladies and gentlemen. We're going to get started on parallelogram proofs. So here's a list of proofs you're going to be able to do kind of by the end of this unit here, proving that if you have a parallelogram, then opposite sides are congruent, opposite angles are congruent, that the diagonals bisect each other, and kind of some reversals here. If the diagonals bisect each other, then it's a parallelogram. Or if the diagonals are congruent, then it's a rectangle. So those are a little bit different kind of proofs. But all of them do require you to just take your parallelogram and split it into triangles. Let's take this first example as our first example. We're trying to prove that opposite sides are congruent. Well, if you take a parallelogram and you split it across a diagonal here, that makes two different triangles. And since it's a parallelogram, we can use a lot of we can use the fact that opposite sides are parallel. So we got these are parallel, and that's a definition of parallelogram. Opposite sides have to be parallel. And since we have some parallel lines, such as this guy and this guy, when you cut it with a transversal, it lets you know that these angles are congruent because they're alternate interior angles. And then down here, we also have those cut by a transversal. And these guys are going to be congruent because they're also alternate interior angles. So since we have a lot of parallel lines, we can use our parallel line angles to establish that we have congruent angles. And what the usefulness of that is, if these angles match and these angles match, we only need one more pair of things to match to show that this triangle up here is congruent to this one. And if those triangles are congruent, then we can say that their corresponding parts are congruent, which would be like this side and this side matching, this side and this side matching. And so that's the general plan. And the side that's going to be congruent, well, it's just this one that we drew. The shared side in the middle is going to be congruent on both triangles. And so that's the game plan. To prove that opposite sides are congruent, we need to show these triangles are congruent, and those triangles are congruent because these angles, pairs of angles are congruent, and then the side between them, and that'd be angle, side, angle. And so we're going to go ahead and write out our proof here. We are given the parallelogram. So we'll start with that. Here, let me get our little T-chart started. Left side, we got some statements. Right side, we got some reasons. Statements, we got reasons. Let's start with our first statement, which is our given. QUAD is a parallelogram. And that's a given. And since it's a parallelogram, we know opposite sides are parallel. We need to establish that they're parallel in order to know that we have alternate interior angles. So we got QU is parallel to, what's that one? QUDA at the bottom there. Okay. And we're going to do the other two there. So that's DQ and AU are parallel. DQ parallel to AU. And that's just definition of parallelogram. Like we know it's a parallelogram, which notes us no opposite sides are parallel. So definition of parallelogram. Nice. So we got that. And on our list so far, we don't actually have this segment on there. That's something we're going to be adding. And so we're going to construct it. We'll just put construct. I think that's QA. Yep, construct QA. Put a line segment over it. And that's just a construction. You can connect any 2 points that you want with constructions. You just line up a straight edge and voila. So now we have our construction there. I guess we can throw in here that it forms angles here. Angles 1, 2, 3, 4. We'll throw that in. That's part of the construction. We're adding some labels to stuff. So there we go. So now we're going to just dive into all those things we had talked about. We have alternate interior angles. We have reflexive property in the middle. And so we can say a bunch of things are congruent. So let's see, we got 1 and 3, 2 and 4. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And that's because they are alternate interior angles. Interior angles. Draw that across there. We got another line coming up, which is QA is congruent to itself, and that's reflexive property. And now we have 3 pairs of things congruent, so we can say this triangle here is congruent to that one. See, so that's QDA, AUQ, QDA congruent to triangle AUQ. And that was angle, side, angle. Oh, I need to make this a little bit longer here. We got another line to write out. Yeah, so I get that part. And we did all this work to show that the triangles are congruent. So we got congruent there, these are congruent, these two are congruent. So now we know the triangles are congruent, and so since the triangles are congruent, their corresponding parts are. So this part corresponds with this one corresponds with this one, and so they're congruent to each other because they correspond. Let's see, so we got, we just write out. So QU is congruent to AD, and DQ is congruent to UA, and that's because corresponding parts of congruent triangles are congruent. And ta-da! There's your first parallelogram proof. And a lot of the parallelogram proofs work the same way. You take your parallelogram, you split it into triangles, you prove those triangles are congruent, and then you can say the parts on the parallelogram are congruent. So we're going to do example 2 here, which kind of goes backwards. So we need to prove that if the diagonals bisect each other, then the quadrilateral is a parallelogram. If you're going to prove a quadrilateral is a parallelogram, well, you have to draw on the definition of parallelograms. So let's go over here to our definitions and theorems at the beginning. Parallelogram, a quadrilateral where both sets of opposite sides are parallel. So we need to prove that the opposite sides are parallel, and that lets us know that it's a parallelogram. Well, how do you prove two sides are parallel? We're going to come up here to parallel lines. Let's see, we need to show that same side interior angles are supplementary, or there's another little thing down here. We're going to use this inverse definition. That's on there, and so you can use it if same side interior angles are supplementary, corresponding angles are congruent, or alternate interior angles are congruent, then the two lines are parallel. So we're going to use this. And that's going to be handy because proving same side interior angles are supplementary is a little bit hard if you don't have like actual angles to do with. But these other ones, corresponding angles are congruent or alternate interior angles are congruent, is a little bit easier if you have congruent triangles, because you can show, well, this angle is congruent to that one. So let's dive down to our proof. So we need to get in alternate interior angles congruent or corresponding angles congruent. Well, let's plan out the proof on what it's going to be. So we have our lovely quadrilateral, and we're given that these diagonals bisect each other. So we got this. Nice. Well, from here, it's actually pretty easy to see that we have some congruent angles because there's a whole bunch of vertical angles here. So we can show that those are congruent to each other. We could show those are congruent to each other. And really, for both of these pairs of triangles, they're congruent to each other, and just a lot of overlapping stuff. They're congruent to each other because of side, angle, side, right? You got side, side, angle between on both pairs of opposite triangles there. And so if they're congruent, then we know things like this angle here and this angle are congruent, and those are alternate interior angles for those two sides. And we know that this angle and this angle are congruent, and those are alternate interior angles for these opposite sides here. And so if we can prove these angles match up and that these angles match up, then we can say that those opposite sides are parallel. And if those opposite sides are parallel, then the whole quadrilateral is a parallelogram. So that's the game plan. We do have to prove both pairs of triangles are congruent, which isn't too bad. You're just going to add more on the line when you write it down. But that's the game plan. Okay, so there's that. We're going to also add some labels on this because I kind of tired of writing 3 letters for angles. So let's name some angles. I'm going to say this is 1 and 2, 3 and 4. And then we're going to need these angles to match up, so we'll label those. And then we got these angles that need to match up, so we'll label those. So, yeah, let's start out our proof. We need some statements. We got some reasons why we can make those statements. Over here, try and draw my lovely T-chart here. Statements. Reasons. All right, let's start with our given. AC and BD bisect each other. Nice. Oh, bisect each other at E. Get that on there. That's a given. Nice. So let's dive into this. So let's write down our segments that are congruent. We got AE, CE, BE, DE. So AE is congruent to CE, and BE is congruent to DE. And that is just definition of bisect. And we can say our angles inside there are congruent. So we got angle 1 congruent to angle 2. Yes. And then angle 3 is congruent to angle 4 for the same reason, being that they are vertical angles. All right, so now we have all sorts of things congruent here in the middle, which means this right triangle and left triangle are congruent, top and bottom are congruent, and that's by side, angle, side. So let me get the names of these right. We got triangle AEB is congruent to triangle, that'd be, sorry, AEB, so that'd be CED for the other triangle. And let's do the other pair there. We got BEC, it's that top triangle congruent to the bottom one, and that's DEA. All right. Yeah, BEC, DEA, nice. And they're congruent by side, angle, side. And the whole point of getting those congruent triangles proven is now we can say that these specific angles are congruent. So we got angle 5 and angle 6 congruent, angle 7 and angle 8 congruent. We want them to be congruent because that shows that alternate interior angles are congruent, which shows the sides are parallel, which shows it's a parallelogram. So now we need to finish this up. So we got angle 5 congruent to angle 6, and angle 7 is congruent to angle 8. That's because corresponding parts of congruent triangles are congruent. And now we have that these opposite sides are parallel. So BC parallel to AD, AB parallel to DC. So AB parallel to DC, and BC is parallel to AD, and that's because alternate interior angles are congruent. are congruent. Nice. And so now we proved opposite sides are parallel, we can say that ABCD is a parallelogram. And that just follows from the definition of parallelogram. All right, there you go. So there's your examples of some parallelogram proofs. I know they're a little bit more intense, but it's not too bad. Usually the first half is just prove a couple triangles are congruent, or two pairs of triangles are congruent, and then you can say things about what's in your shape there. So hopefully that gives you get started on your assignment. Give it a shot, try out those proofs on your own, and may the force be with you.